our goal here is to evaluate this given integral. We have given on the integrand as the function sine of 9x. Underneath that we have 1 plus square of cosine 9x, right? And then I hope you recognize this is the definite integral, because we have something over here on the lower limit of integration, and then we have something over here at the upper limit of integration, right? So that's what we have. So how do you evaluate the definite integral? We can use the fundamental theorem of calculus, right? But if you want to use the fundamental theorem of calculus, what we need is the entire derivative of this integrand. So let's do it in this way. First, try to just focus on finding the entire derivative of this integral over here, given as sine of 9x, right? Sine of 9x, and then underneath that we have 1 plus square of cosine 9x. So that's what the function we have given. Our goal, let's first goal is to find the entire derivative of that. Once we have that, we can use the fundamental theorem of calculus. So let's do that. Okay, so how do we find the entire derivative of this function? Doesn't look like we can use just some basic formula, or just find the functions whose derivative is this. It's really challenging to like use the reverse process of the differentiation, right? And then not direct formula we can apply. So we need to think about something else then. If you look into this, the structure of this function, as I hope you recognize, there is something going on over here. If I actually assume u is equal to cosine of 9x, then and then find the differential du, then you can see that the derivative of the cosine is actually what? Negative sign, right? And then it is composed with 9x, so times 9. So we have that expression, the sine of 9x at the top. So if that is the case, I think that the substitution rule would actually work here. So if substitution rule works, so we need to introduce this u variable to substitute for one of the expressions. So what I have done over here is try with cosine of 9x, and then when I do that, differential du is a negative 9 times a sine of 9x, right? So that's what we get, it multiplied by differential dx. So that's what my differential du. So let's use this substitution in our problem to see if we get the simpler integral. So at the bottom now we have 1 plus, with that substitution, u equal to cosine of 9x, we have 1 plus u square, right? And then if you look into the top, we have sine of 9x times dx, and this is somehow similar like we have over here, sine of 9x times dx. What is extra is negative 9, but we can divide both side by negative 9 here. And then if we solve for sine of 9x times dx, we exactly get this is equal to negative 1 over 9 times du, right? So that's exactly we can substitute here on the given integrand. So if that is the case, we can write down this is something like 1 over 1 plus u square times negative 1 over 9 times du. And negative 1 over 9 is actually just a constant. We can take that out. On that case, we have just 1 over 1 plus u square du. And what can we do here? Oh, this look like the integral that we know actually, the corresponding formula. If you recall, the derivative of the inverse tangent, that was something like what? 1 over 1 plus x squared. So doing the reverse process of the differentiation, we can say that if you have 1 over 1 plus x squared, then its entire derivative is inverse tangent of x plus the arbitrary constant, right? The integration constant. So in that case, we have here negative 1 over 9 times inverse tangent of u plus c. So we were able to integrate, but don't forget to replace back the variable u, right? So inverse tangent of u is actually cosine of 9x, so we can actually just write that down over here, plus c. Okay, so this is nice. So we were able to figure out the entire derivative of the function sine of 9x over 1 plus square of cosine of 9x. So we have the entire derivative, but our main goal here is to evaluate this definite integral, right? So we're going to use the fundamental theorem of calculus here. So let's use this entire derivative that we have figured out to use the fundamental theorem of calculus, which is how to apply the fundamental theorem of calculus. We need to evaluate this entire derivative, which is negative 1 over 9 inverse tangent of cosine of 9x, right? We need to evaluate this entire derivative at the upper limit of integration, at lower limit of integration, and just find the difference. So if that is the case, then what do we get here? This will be equal to negative 1 over 9 times inverse tangent of cosine of 9 times pi over 18. So that's what we have when we evaluate this at the upper limit of integration, minus, right? And then we have negative 1 over 9 inverse tangent of cosine of 0, right? So this is what we have. So if that is the case, now actually just try to simplify this. We have negative 1 over 9 and inverse tangent of cosine of 9 pi over 18. So we have then cosine of pi over 2, right? And then negative negative positive, so we have positive 1 over 9 inverse tangent of cosine of 0. Am I having correct amount of what the parent? This is okay, that will work. All right, so if you look into here, this is cosine pi over 2. What is the value of cosine pi over 2? Cosine pi over 2 is what? So if you look into the unit circle here, right, the value of the cosine pi over 2, so this is pi over 2, and then cosine relates with the what cosine relates with the x coordinate, right? And then y relates with the sine, right? So if that is the case, then the value of the cosine pi over 2 is 0, right? So if on that case, we have to figure out then what is the value of the inverse tangent of 0. And what is the value of the inverse tangent of 0? Inverse tangent of 0 is 0, right? Okay, so that's what we can write down over here. Then this is the first term vanishes. But if you look into now the second term, we have what do we have here? Cosine 0. Cosine 0 is 1, right? And then what is inverse tangent of 1? So the inverse tangent of 1 is pi over 4. Okay, then we have plus negative 1 over 9 inverse tangent of 0 plus 1 over 9 inverse tangent of 1, and then the first term vanishes, so this is 0, and then the second term is 1 over 9 times pi over 4. So what we have over here is pi over 36, and this is the evaluation of the integral that is given in our example.